Hey, Chem students, I want to take just a brief moment to give you a few additional examples of isotopes here on the board. I'm going to model some isotopes and talk you through some things. Okay, so let's go back to the video lesson 5 and look at the carbon atom or carbon element and the 3 isotopes that make up carbon, right? So if you look at your periodic table, the atomic number for carbon is 6, as we've discussed before. So what I'm going to do is I'm going to make a nucleus of the 3 isotopes of carbon. So I got some protons and neutrons here. So we grab some. Right. So I'm just gonna up here make 1, 2, 3, 4, 5, and 6. So this is going to be one nucleus of carbon atom. Here's another one. 1, 2, 3, 4, 5, and 6. Again, we know this is carbon just because it has 6 protons. And then the last one, 1, 2, 3, 4, 5, and 6. Okay, so we have 3 starting our 3 nucleuses of carbon. And then we have neutrons. And so we have one isotope that we know has 6 neutrons in that nucleus. So 1, 2, 3, 4, 5, and 6. And then we have another one with 7. 1, 2, 3, 4, 5, 6, 7. And then the last one has 8 in the nucleus. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I'm not putting any electrons around those nucleuses in electron shells because I don't need to worry about the electrons when it comes to identifying an atom and its isotopes. Okay. So for this first one, as we mentioned before, we would actually identify this by writing out carbon with a hyphen, and it would be 12 with the mass number, okay? So the mass number is 12 for this carbon atom because, again, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 particles in the nucleus, okay? Symbolically, we would represent this as carbon with an atomic number of 6 and 12 with the mass number up in that corner, okay? So that's how we would write this. For this isotope, this would be carbon hyphen 13 with the mass number of 13 because of the total number of particles in the nucleus when we add them up. Symbolically, we'd write this as carbon, 6 protons, so the atomic number and the mass number up there in that corner. And then finally, the last one would be known as carbon hyphen 14, so carbon 14. Its symbol would be 6 protons and a mass number of 14, stuff like that. So these are the 2 ways in which we would represent an isotope's name, either by identifying its element name with a hyphen and then the mass number, element name, hyphen, mass number, element name, hyphen, mass number, or by using the symbol that we have up here that we're representing. And then remember, we also said that these 3 isotopes of carbon don't exist in the same abundance. Carbon 12 is the most abundant isotope of the element carbon that we find in nature. Find more of this in any other atom of carbon. Carbon-14 is by far the least common. Only a very small percentage, right? Remember, about less than 0.1% of all carbon atoms are carbon-14 found in nature. Now, on the idea though, is that all three of these types of atoms exist in the element carbon, and therefore, or make up the element carbon. Therefore, for us as humans, we are carbon-based organisms. So we are actually, in our bodies, we have incorporated all three of these atoms into our bodies, whether it be in our proteins, our carbohydrates, our nucleic acids such as DNA and RNA, but our fats and so forth, anything that has carbon in it that we eat and consume as food and become building blocks in our body, we have all three of those carbon atoms. Now, carbon-12 is not radioactive. We'll talk about radioactivity later, but carbon-14 is. And carbon-14, because it's radioactive, we have this radioactive element, or sorry, radioactive atom in our bodies, right? We ourselves produce radiation, and therefore we use radioactive dating to determine when something died that is carbon-based. And that will be a discussion we'll talk about later, okay? So keep those in mind. All right, let's do one more example. Let's do one you haven't seen yet. Let's do like boron. Okay, so if I'm going to do boron, okay, only has an atomic number of 5. So it has one less proton in its nucleus, okay? And actually, I'm going to get rid of an entire nucleus because boron is only going to have 2 isotopes. So I'm going to get rid of all of this. Okay, the 2 isotopes are boron 10 and boron 11, okay? Boron 10 and 11. So they both have 5 protons, of course, because they're isotopes of the same element, boron. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. But how many neutrons are in the nucleus? Well, boron 10, because it has a mass number of 10, okay? If I take 10 minus 5, the proton number, I get 5 neutrons. So there should be 1, 2, 3, 4, 5 neutrons in the nucleus of boron 10. And I would write this symbol, boron, 5 protons, and a mass number of 10. Okay? Well, what about boron 11? Well, it also has 5 protons, because that's the atomic number, but what about the number of neutrons would it have? Well, because its mass number is 11, 11 minus 5 should be 6. So therefore, it has 6 neutrons in the nucleus. 1, 2, 3, 4. Oops, I lost a proton. Okay, so 1, 2, 3, 4, 5, and 6. Okay, so that would be an example of boron 11 symbol with its 5 protons and mass number of 11. Okay, so these are the 2 isotopes of boron that we find in nature. Okay, so I hope this clears up some things. If you need to rewatch this, do so. But this is our little mini video on on isotopes. Okay, so that's it for today.